Okay, if you remember, we've done composition. Composition is where we put one function inside of another function. So it was this notation right here, and we did it in the first semester. And so if you remember, when I have like instead of f of x, if I have f of 3, that means I replace this x with a 3. So it would be 3 times 3 plus 1, which would be 10. So f of 3 is 10. So we just replace whatever is in the parentheses we put in for x. So, and look in this next one. What's in the parentheses? A 2. So I'm going to do 3 times 2 squared plus 1. So that's 4, 12, 13. So g of 2 is 13. This next one, sorry, it should have an equal sign right here in the middle. So I'm going to replace the 3 with an 8. So, I'm going to replace the x with a 3, sorry. The answer, in my head, I was already saying, is the square root of 8, which, if you remember, breaks down to 2 root 2. But I would take either one of those. Okay, so that's evaluation. So composition, we're not going to put a number, but we're going to put another function. So first, what type of equations are these? These are linear. These are linear equations, and we are going to put g inside of f. Okay, I have a little bit better slide here, more room. So this is linear, and the first thing I'm going to do is I'm going to put g inside of f. So f is 3x plus 1. So I'm going to do 3, and I'm going to replace the x with x minus 9. Okay, so just let me write that even a different way because I want to make sure we understand this concept. Another way to write it would be, okay, if I want f of g of x, then I'm going to put g of x inside of wherever x was. Well, what is g of x? X minus 9. So then I can do some distribution. 3x minus 27 plus 1, 3x minus 26. So f of g of x is 3x minus 26. Okay? Now, this next one is going to be g of f of 2. G of f of 2. So first I'm going to put 2 in for f. So 3 times 2 plus 1, and I get 7. Then I'm going to put that into g. 7 minus 9. So g of f of 2 is negative 2. Okay, so one more time. I put 2 in for f, then I put that answer into g. Okay, so let's look at this next one. Now what kind of equations do we have here? I still have one linear. What's the other one? Hopefully you said quadratic. Okay, so first I'm going to put g inside of f. So 3, and instead of x, what am I going to put in place of x? X plus 2 minus 5. Now, if you remember, I have to FOIL out the x plus 2's. This is a little bit of some tricky algebra to remember, but I know you can do it. You just have to watch it slowly, maybe watch it twice. So x times x is x squared plus 2x plus 2x plus 4. Okay, so what I just did there was I just did my double distribution, my FOIL, whatever you want to call it. I'm going to combine like terms. Okay, now I'm going to distribute the 3. Now I'll subtract 5. So my final answer is 3x squared plus 12x plus 7. Okay, that is f of g of x, meaning I put the function g of x inside the function f of x. G of x is inside the function f of x. Okay, now I want g of f of negative 3. So I'm going to start here. I'm going to do f of negative 3. So 3 times negative 3 squared minus 5 Any negative number squared is positive. So 3 times positive 9 is 27, minus 5 is 22. Okay, then I'm going to take 22 plus 2, so I'm going to write that up a little bit higher. 22 plus 2, because now I'm doing g of 22, and I get 24. So g of f of negative 3 is 24. Okay, now there's 2 more that I want you to look at. So for this next one, we have a radical, or a square root, however you want to, both words mean the same, and a linear. Okay, so first I'm going to put g inside of f. G inside of f. So the square root of, I'm going to replace that x with 2x minus 1 plus 5. Okay, the only like terms right here are a negative 1 and a 5. So I have 2x plus 4. That cannot be simplified. There is nothing that can be done. That is the answer. So f of g of x is the square root of 2x plus 4. Okay, now I'm going to reverse it. I'm going to do g of f of x. So instead of putting g inside of f, I'm going to put f inside of g. So 2, I'm going to replace that with the square root of x minus 5, sorry, x plus 5, minus 1. Okay, I could drop the parentheses. They're pretty much no longer, not really necessary. But other than that, there is no simplification I can do further. So g of f of x equals 2 square root x plus 5 minus 1. Just make sure your house only goes over the x plus 5 and that the minus 1 is here at the end. Okay, just to review, if I wanted to practice, I got that a little bit big. Which way would this function shift? This function would shift left 5 and down 1 and would have a vertical stretch. Okay, last one. So now I have a quadratic here and a square root or a radical here. Okay, so first I'm going to put g inside. So I'm going to replace x with g of x. That's it. That's all I can do. I know there's something squared, but because it's doing subtraction first, I can't simplify it any further. So that's all I can do. Now I'm going to put f inside of g. So this one I will be able to do something with. I'm going to take the square root of x minus 3 and square it. Okay? Square root and squaring undo each other, so I end up with 4x minus 3, which is 4x minus 12. Okay? So g of f of x is 4x minus 12. Okay, so this is inverse. I'm sorry, this is composition. Composition. So you're putting one function inside of another function for composition. And like I said, it's a word that we've seen before, and it's we did it with just linear functions, so now we're just expanding that to quadratic and to square root functions. So tomorrow I'll answer questions. Please take good notes and have anything that you didn't understand, write it down, so you'll be ready to practice tomorrow. We're also hopefully going to go over our CFAs tomorrow, and so I want to have plenty of time to do both of those things. So have a great evening.